Hi everyone, so today we'll discuss the subject of specific heat capacity. And before we start, let's discuss some daily example. If we are going to the beach, especially on summer, we will all feel cool water and hot sand. Anyway, the sun is warming also the water and the sand, and we can ask why the water is much cooler than the sand. An interesting question. Another example, when we are heating food in a pot or something and the food is really hot, and then we put some spoon in the food, in the hot food, we will feel that when we put a metal spoon, the spoon will be really hot, and then when we put a wooden spoon, the spoon will be maybe a bit warm but much cooler than the metal spoon. And the question is why? Why those phenomena are happening? And the answer for all these questions is a definition of a topic, a term called specific heat capacity. And when we are talking about specific heat capacity, we are talking about the fact that different materials heat up in different rates. So the term specific heat capacity is actually the amount of energy, a heat energy, that required to change the temperature of one mass unit of a substance by 1 degree Celsius. So the specific heat capacity actually has units of energy per mass per degree. Each material has different specific heat capacity. Let's look at it again. We said a specific heat capacity is the amount of energy required to change the temperature of one mass unit of a substance by 1 degree Celsius. That's why the units of specific heat capacity, which we are signing by the letter C, is the units of energy, which is joule per 1 kilogram per 1 degree Celsius. Now let's table. We can see that aluminium, for example, has a specific heat capacity smaller than 1, and the meaning is actually the 0.89 is the amount of energy that we need to heat 1 kilogram of aluminium by 1 degree Celsius. We will need a bit less than 1 kilojoule in order to do it. And we can see that the specific heat capacity of the sand is a bit smaller, and what we can see here that the water has a really big specific heat capacity. That means that we need a lot of energy in order to heat 1 kilogram of water by 1 degree Celsius. And that's an important fact. What we can see here is 1 kilogram of water and 1 kilogram of sand, and the water is warmed by high energy source and the sand is warmed by a lower energy source. And as we can see in this animation, that also the water and the sand are heated by the same temperature difference. And we see that in order to heat the water we need a high energy source, and in order to heat the 1 kilogram of sand we need lower energy source. So that's actually the meaning of specific heat capacity. We see it's easier to heat 1 kilogram of sand. That means that the sand has much lower specific heat capacity. So what we said till now, that specific heat capacity is actually the amount of energy per unit of mass per degree Celsius. So if we're just writing it, we can say that C, the specific heat capacity, is the energy per mass per temperature difference. And if we are multiplying the two signs of the equation by the denominator, we can say that the energy that required to heating something equals C multiplying by mass multiplying by the temperature difference. And we can make a formula from it. The formula is Q equals Cm delta T, when Q is the heat energy that required to heat a material that has specific heat capacity, which is C, and the mass of the material is M, and delta T is the temperature difference that we want to heat the specific material. So let's look at a simple example. The question is that we want to boil 1 kilogram of water from 20 degrees Celsius to 80 degrees Celsius, and the question is how much energy should we invest in order to do it. And we remind you from the table before that the specific heat capacity of water is 4.18 kilojoule per kilogram per degree Celsius. In order to solve it, let's organize what we know, the information that we know. And we know the specific heat capacity of water, we know the initial temperature, which is 20 degrees Celsius, and we know the final temperature that we want to reach, which is 80 degrees Celsius, and the mass is 1 kilogram. And now all what we need is to put this information in the formula, which means Q equals mc delta T, and when we put the numbers in the formula, we get 251 kilojoule. The numbers are less important, but we have to understand the answer that we got. That means that in order to heat water from 20 degrees to 80 degrees, we need to invest 251 kilojoule of energy in order to heat 1 kilogram of water. Another example dealing a story about a bottle of water, 1 kilogram of water, and a bag of sand, which is 3.5 kilogram. Both the water and the sand are at the same temperature at the beginning, and they are both heated by the same heater. And the question is which one will reach higher temperature after an hour. And student A, the female student, says that obviously the water, because it's 2.5 kilogram less in weight than the sand. And student B, the male student, says that the sand has smaller specific heat, and that's why he will choose the sand. So we have an interesting question here that has two aspects. The water is less heavier, but the sand has a smaller specific heat capacity. We have two aspects here, so it's an interesting question. In order to answer it, let's talk about the sand and the water separately. As we know, the formula is Q equals Cm delta T, and when we are looking at the water and we are insulating the delta T, that one is interesting us, we get the delta T equals Q divided by M multiplied by C. And if we put the numbers and the information that we know, we get that the delta T of the water equals Q divided by 4.18. So actually we got something which is not number, it's a phrase, and we don't know nothing about it, we don't know nothing about Q. But let's look at the sand and at the phrase that we'll get for the sand, and we'll try to get from it something. And if we are talking about the sand, we are get the delta 2 of the sand is Q divided by M of the sand and C of the sand, and when we put the numbers we get that the delta T of the sand is Q divided by 2.59. And we don't know what is Q of the water and what is Q of the sand, but we are told then that they are both heated by the same heater, which means the Q that invested in warming the sand and in warming the water is the same. So what we know is Q here and Q here is equal, and that's why it's obvious that delta T1 is smaller than delta T2. So take a second to think who is the winner here. And if you remember, the student B says that delta T of the sand will be smaller, and that's the right question. And it was an interesting question combining two aspects. Also the C and the mass is not the same. So if we are summarizing, we talked about specific heat capacity, which is the amount of energy needed to heat 1 unit of mass by 1 degree, and we said that different materials have different specific heat capacity, and thus we saw the water has much higher specific heat capacity than the sand, and that's actually answering the question that we introduced at the beginning. We talked about a beach and the cool water and the warm sand, and actually the sand is much hotter than the water, and the reason for it it's that the sand has much lower specific heat capacity, and that's why it's easier to warm it. So that's why the sand and the water are warmed by the sun, and the sand is much warm than the cool water. So we hope you learned something today, and thank you very much for listening to us. Thank you, bye bye.